Okay, AP Challenge. This is 2018. Question number 3A is the one we're going to do in this video. Okay, so we'll just write part A. Okay, we have the graph of G right here, excuse me, and the graph of G is continuous on G, and the derivative, okay, of the function f. So G is the derivative of the function f. So wait a second, let me write that down. So G is the derivative of the function f. Okay. I think that's what that means, right? It means that if I take the derivative of f, I'll get G. Okay, I got that. The function G is piecewise linear from -5 to 3. Okay. And then from there on, g of x is equal to this function. That's where you're getting this curve, it seems. 2 times x minus 4 squared for 3 to 6. Okay, so there's the piece right there. Okay, A says f of 1 is equal to 3. What is the value of f of -5? So, the quick way to write this is just to realize that if g is equal to the derivative of f, then f of x is equal to the integral of g of x. Okay, so that's kind of the key idea right there. You kind of had a hint down here. Okay, you're also looking for f, so you have to figure out what is g in terms of f, and you have to be able to go from derivative to integral and integral to derivative. Okay, so with that, they want us to find f of 1. Given f of 1 is 3, what is the value of f of 5? So let's see if I can set this integral up. They want the integral. You know, it might be natural to set it up one way or the other. I don't know if someone's going to start with -5 to 1, but let's just say they went from 1 to -5. And that's fine. And we know that if we integrate g of x dx, ftc1 here, okay, ftc1 says we can write this as f of -5 minus f of 1. Okay, so couple things. Okay, so we want to get f of -5 by itself, because that's what we're looking for. And they love this move. They love when you solve for a part of the leftovers once you integrate. Either it's the first guy or the second guy. And you just have to manipulate your function here a little bit. And I think that would be, oh, how would I write this? So f of -5 is staying on that side, so I'm bringing the other guy over. So it's f of 1 plus the integral from 1 to -5 g of x d of x. And then you guys should be saying, well, that guy's backwards, so I'm going to rewrite it. And then you're left with f of -5 is equal to f of 1 minus, okay, the integral from -5 to 1, because we want to go in the right order. And you would have wound up this way also if you switched the limits in the beginning. You would wind up in the same spot if you didn't notice. But solving for one of these guys over here, okay, is something to pay attention to. So pay attention to you know, solving for one of the values of the antiderivatives. Okay, let's see if we can do that. So now here we see that f of -5 is equal to, well, f of 1 was given to be 3 minus, okay, now we have some work to do. We have to integrate this thing from -5 to 1. We have to integrate g. So here's g, and we want to integrate from -5 to 1. So we got to get all these nice shapes in here. Here's a nice square or rectangle. Here's a triangle in here. This is flat, so don't have to worry about that. And then here's a nice triangle up here. Okay, so the first one, let's see, that's what? Keep the negatives because it's a geometric argument, and that's a 3 up here. That's a 1 and a -3 for that triangle. That's a 2 and that's a 1. Okay, so 3 times -3 is -9, and then plus 1/2 that triangle, 3 times 1, plus, well, that's blank, so that's a 0, and 1/2 1 times 2. All right, let's see if we can clean this up. That's 3 minus, anything good we can get out of there? Looks like a -9 minus 3 halves plus 1. And yeah, you just have to add some fractions here, I guess. You know, you could actually leave your answer like this, and if you left it like this, they would give you full credit. All right. You could do it all out, and if you did it all out, you would get 25 over 2. But again, if you just leave everything in terms of numbers, the AP and I will accept that as a full answer. Just make sure your numbers are right, of course. Okay, part A done.